So welcome everybody to this latest video on 162 Maths, and in this video we'll be going over a series of GCSE Maths High Revision Big Mark questions on the following topics. Now as always there'll be a copy of the questions in the description below, which I strongly recommend you have an attempt at before watching through this video, and also include the mark scheme, as the method shown in this video might differ from the one you may choose but still come out with the correct answer. So the 5 questions we're going to look at in this video are as follows. So the first question is regarding functions and exclusive functions with the inclusion of inverse and composite functions. Question 2 is trigonometry with the use of the sine rule for working out the area. Question 3 is a massive mixture of equations of a circle, ratios and trigonometry. Question 4 is perimeter of a sector in a circle, which are nicely linked. And the final question is a 5-mark question on direct and indirect proportion. So looking at question 1, it says f of x equals a half x, g of x equals x minus x squared, and we need to solve the inverse function of f equaling gf of x. So the first thing we need to do before solving this particular equation is to first of all find what the inverse function of f is and what gf of x is. So here for the inverse function of f, then here what we need to do is first of all make y equal to f of x. Now I'm just going to rewrite this as x over 2, which is the same thing, and then I make x the subject, so I'm going to end up with 2y equals x, and then I swap the x for the inverse function of x and I swap the y with x, so the inverse function of f is 2x. The next thing for me then to work out is what gf of x is, so gf of x. Now for this, what you want to do is you want to substitute f of x in as x in the function of g. So here what this is then going to become is, if I write down the function of g of x, now instead of writing x I'm going to write a half x instead. So here all I'm going to do is write this as that and just put that in brackets. So then what this then becomes, so if I just write that in blue, so all I've done is wherever I see an x in the g of x, I've swapped it with the function of f. So then if I just neaten all of that up, what does it then become? It becomes gf of x equals x over 2 minus x squared over 4. Now you don't have to put the brackets, let me just get rid of those because it can be a little bit confusing. So now that I've got the components, what I can now do, and let me just highlight this here, is I'll now need to make these two boxes equal to each other. So here I've got 2x equals x over 2 minus x squared over 4. Now what you want to do here is try and have a common, we want to try and get rid of those fractions. So the best way of getting rid of those fractions is to multiply everything by 4. So if I multiply everything by 4, 2x then becomes 8x. X over 2, well that then becomes 4x over 2, which then just becomes 2x. And x squared over 4 times 4, well the 4's cancel out, so I'm just left with x squared. And then from this, what you then want to do is to take all of this over to the side, because it looks like a quadratic. So we've got x squared, and it's going to be plus 6x equals 0, and then we just need to then go on and solve this quadratic, in which we've got a common factor of x equals 0. So here either x equals 0 or minus 6, and there is our final answer. Now if you wanted to, you could use a quadratic formula where a equals 1, b equals positive 6 and c equals 0, in which you'd still come out with the same answers, but generally speaking that would be our answer when we factorize. Now looking at question 2, it says ABC and ACD are triangles, and it says the area of ACD is 80.5, and we need to work out the area of triangle ABC. We need to give our answer to 3 significant figures. Now looking at the triangle of ABC, you can see here that we're not given the height of that triangle, so we're going to have to use the formula of a half AB sine C. So if I label this particular triangle, this angle here is going to be C, so this is going to be A, and this side here is going to be B. Now I don't know what B is, so I need to find that, and I can use that by using this information here and the information that we're given on the triangle ACD. Now looking at the area of ACD, that's 80.5, and to work out the area of a triangle, when we know the height and it's a right angle, it's basically base times height divided by 2. So looking at this, we're going to have 80.5, well 14 times B divided by 2 equals 80.5. Now try not to get too confused about B representing the base. In this part our height is B, so just be wary of the letters that you're using, but it shouldn't really make a difference. So here I've got 14B equals 161, so therefore B is going to equal 11.5. So this length here is 11.5. So from that, what I can then do is work out the area of ABC, and it's going to be a half times 19 times 11.5 multiplied by sine of 36. Now if I type that all into my calculator, I should have an answer of 64.2, and that's going to be in centimeters squared, and that's to 3 significant figures. Moving on to question 3, it says that in this question, let me just zoom out a little bit, and there we go, let's try and get the whole question on the screen. So it says, in this question, all lengths are in centimetres. A is a point on the circle with centre O, and it says B is a point on a different circle with centre O, and it says that AB is 20. The equation of the larger circle is x squared plus y squared equals 144, and the radius of the smaller circle to the radius of the larger circle is in the radius of 4 to 5. And the question is asking us to work out the size of angle AOB. So this is the angle that we need to try and find. Now in order to try and find that angle, we need to know what all 3 sides of that triangle are going to be. So let me just zoom in a little bit, and we know that this is 20, and I know that's 20 because it tells me there. So let's have a look at what the other information tells me to try and work this out, and just while I configure the screen just so it's a little bit bigger, and there we go. So from this bit of information here, now the equation of a circle, this 144 is the radius squared, so that means that the radius is going to be 12. Now it can't be plus or minus 12, so we don't need to worry too much about that because obviously we're dealing with length. So that means that's the radius of the large circle, so OB is going to be 12. Now using this bit of information here, that the radius of the smaller circle, so if I just write this here, so the radius of the larger circle to the radius of the smaller circle is 5 to 4. Now just note how I've written it in the opposite order to what's given to me in the question, just because it's a lot easier for me to work with. Now from this I know that the radius of the large circle is 12, so 5 parts equals 12, so 1 part is going to be 12 divided by 5, and if I work that out, so 12 divided by 5 gives me 2.4, and so 4 parts is going to be 2.4 times 4, which gives me an answer of 9.6. So then this length here is going to be 9.6. So from this, what I've now know is I know all the 3 sides of the triangle, so I can use the cosine rule to work out what the angle AOB is going to be. So here I've got, let me just write down the formula and try and write it correctly, minus a squared over 2bc. So labeling this triangle, I've got this as being A, that's going to be little a, that's going to be B, and that's going to be curly cut. So substitute the numbers in, I get cos A equals, and it's going to be 9.6 squared plus 12 squared minus 20 squared, all divided by 2 times 9.6 times 12. And if I type that all into my calculator, I get my cos A value, and that's going to be a very long decimal number. So let me just quickly type that in. So 9.6 squared plus 12 squared minus 20 squared over 2 times 9.6 times 12. and we get an answer of minus 32 over 45. So minus 32 over 45. Now don't worry about the negative answer of that, because we then need to work out the inverse cos of that number. Now if you've already got it on your calculator, just use the ans function. But basically, if we just do that, we should have an answer of 135.3 degrees, and that's to 1 decimal place. Moving on to question 4, it says here is a circle and a sector of a circle, and they all have a radius of r. And the question is asking us to work out the size of x, given that the circumference of the circle is equal to the perimeter of the sector. So let's have a look at working out the circumference of the circle. So here, the circumference of the circle is going to be 2 pi r. Then if we work out the perimeter of the sector, then that's going to be x over 360 multiplied by 2 pi r and plus 2r. Now if I neaten all of this bit up, and let's just do just that. So here I've got 2 pi rx over 360 plus 2r. Now what I then need to do is I need to make this equal to this. So let's just do just that, and I'll do that over down a little bit if I can move the computer to work. So here I've got 2 pi rx over 360 plus 2r equals 2 pi r. Now notice that the question is asking me to give it in terms of pi, so there's a good chance that this is going to appear on a non-calculator question, paper rather. So from this, let's just try and neaten all of this up and see if there's anything that cancels out. Well, I can cancel that with that just so I'm dealing with smaller numbers. So I've got pi rx over 180 plus 2r equals 2 pi r. Now, one thing you should be able to notice is that, let's focus on getting rid of this 180. So if I multiply everything by 180, so I multiply this by 180, that by 180, and this by 180, then what I'm left with is pi rx plus 360r equals 360 pi r. Now one thing you should notice that each of the terms all has r, so I can cancel them out. So what I'm left with is pi x plus 360 equals 360 pi. Now I want to try and get x the subject, so what I can do is if I take everything that hasn't got an x over to the other side, so here, well, let's try and get rid of the pi. So from this I get pi x equals 360 pi minus 360, and then I can just divide by pi. So pi x equals 360 pi minus 360, all divided by pi. Now there's a number of ways in which you could write this answer out, so that would be absolutely fine. Or I could write this answer as 360 minus 360 over pi. Or what I could do is do a bit of factorising, and I could write 360 pi minus 1 all over pi equals x. So any of those would be absolutely fine as your final answer to get the full marks. Moving on to question 5, it says P, Q, R have positive values. Now it's really important that we acknowledge the positive values because that will come up in a second. It then says that P is directly proportional to the square of Q, and it says that we've got our values, and it also says that Q is inversely proportional to R. We need to find R when P equals 0.8. Now this is quite a big mark question, only because we've got a lot of things to do. So first of all, let's translate this bit of information here. So looking at this, we know that P is directly proportional to Q squared, and what you want to try and do is find the formulas of each of these. So here we've got P equals K times Q squared, and then from this we need to find out the value of K, so I use and substitute those numbers into this. So here I've got 1.25 equals k times 0.5 squared. So k equals 1.25 divided by 0.5 squared, and that gives me an answer of, and if I just type that into my calculator, it gives me a value of 5. So therefore the formula is P equals 5q squared. I'm just going to put a little box around that. The next thing for me then to do is to work with this here. So from this we know that Q is inversely proportional to R. So then I get rid of the proportional symbol by writing it equal to K over R. Then I use these numbers to try and work out what the K value is for this. So here I've got 0.5 equals K over 6. So K equals 3. So therefore the formula for Q in terms of R is going to be Q equals 3 over R. Now from this, what I'm then going to do is to then work out what they actually want me to do. So here, when P equals 0.8, I need to try and find out what Q is. So here it's going to be 0.8 equals 5q squared. So here I've got 0.8 divided by 5 equals q squared. And if I type that in to my calculator, I get that Q equals plus or minus, and it's going to be 2 over 5. Now remember that it does say that Q needs to be positive values, so I can get rid of that negative and just deal with 2 over 5. Then from this, when Q equals 2 over 5, I'm now going to use this formula here, so I get 2 over 5 equals 3 over R. And then from that I can just cross multiply or try and get equivalent fractions. So here it's going to be 2R equals 15. So R equals 15 over 2 or 7.5. So any of those answers would be fine for the 5 marks.